Let's continue with adding numbers in different base system, and today we're going to add numbers in the base 2 counting. This is also well known as the binary system, very popular nowadays. So what are the numbers we use in base 2? There's only two symbols, and that's 0 and 1. It's a very interesting way to do it. So the place value that we use are essentially quite easy. So it will be ones, yeah, that's 2 raised to the power of 0, which is exactly the same as 1. And then 2 raised to the power of 1, which is 2. And 2 raised to the power of 2, which is 4. And of course, you can continue, with the different exponents of 2's. 2 raised to the power of 3 is 8. So let's jump in with an example. Let's say we have one group of 4, 0 group of 2, and 1 group of 1 in base 2. We're going to add one group of 1, one group of 2, and one group of 1. Now I'll just do this once because some people will just probably turn into this one without knowledge of what we've done in the past. So this number would look like one group of 4. Yeah. So let's start with it. There's one. One group, 1 0 of this, and then one group of 4. It will be 1 2 3 4. Yeah, which is like this, which looks like this. So this is 2 raised to the power of 2. This is 2 raised to the power of, and this is how it's represented. So essentially 1 0 1 in base 2 is like 5 in our number system, 5 in base 10. But if you know more, if you want to know more of this, please check the other videos earlier in the series of presentations. So let's continue adding this. And it will be 1 plus 1 is 2. Well, can we write 2? Yeah, can we write 2? We can't. We're only allowed these numbers, 0 and 1. So the question is, how many 2's are there in 2? How many 2's are there in 2? The answer would be 1, remainder 0. So the answer is going to be 1, remainder 0. So instead of carrying it in here, just like in what other schools do, I'll carry it in here. 1, remainder 0. So 1 plus 1, 1 plus 1 is 1, remainder 0. That's your answer. Then we go to the next bit. It will be 0 plus 1 plus 1. And the answer would be 2 again. We cannot write 2, so we're back here again. Yeah. How many 2's? Yeah. How many 2's goes to 2? And the answer is 1, remainder 0, which is what we need to put in here. It's going to be 1, remainder 0. And then we'll continue doing the same thing. It'll be 1 plus, there's nothing here, but there's the carry. 1 plus remainder, 1 plus 1 is 2. We cannot write it, so we're back to this again. So the answer is 1, remainder 0. There's no more, so we'll just have to bring this down. And so the answer to this whole addition question is 1 0 0 0 in base 2. Very interesting way. Let's have another example. Now let me just rub this out. Okay, let's have another example. Let us say, okay, let me just write all of the exponents in here. We'll do it very quickly. Okay, let us say we got 1, 1, 0, 1 plus 1, 1, 1. All of them in base 2. So 1 plus 1 is 2. We cannot do it. Now we know from the past that 1 plus 1 is just 1, 0. So we do 0 plus 1 is 1. Add the 1 that you carried over is another 2, which is basically we cannot write because we're not allowed to write 2. So 1 plus 1 is 1, 0. Now here's what it is. 1 plus 1 plus 1. It's 3. Can we write 3? We can't. We're only allowed these two symbols. And so what do we need to do? We kind of ask this question. How many 2's are there in 3? And your answer is 1, remainder 1. And so your answer here is 1, remainder 1. So we're on our last bit. It's going to be 1 plus nothing here, but it's 1, it's basically 1 plus 1 is 2, which is another 1, 0. You bring this one down. So your answer is 1, 0, 1, 0, 0 in base 2. So in a way, you don't have to remember much, but it's just the number gets larger. Well, not larger, but the digit goes longer. So I want to give you some homework, as I always do. I'd like you to solve this. What is 1, 0, 1, 0 in base 2? Add 1 and 1 in base 2. The other question would be, what is 1, 1, 0, 0 and then 1, 1, 1 all in base 2? Let me know your answers in the comment section below. So in the next series of videos, we'll focus on subtracting numbers in base 2.